All right, so to finish out chapter 13, let's go ahead and do one more example. So this is problem 13.88 in the textbook. The value of a sports franchise is directly related to the amount of revenue that it can generate. So this data set gives us the value in 2017 in millions of dollars and the annual revenue in millions of dollars for 30 Major League Baseball franchises. So suppose you want to develop a simple linear regression model to predict franchise value based on annual revenue generated. So let's go ahead and do that. So it has a couple things for us to do. The first is construct a scatter plot, and then use least squares method to find our coefficients, and then we'll interpret those and do some predictions. So let's do that step by step. So we'll create all of these tables and plots in Excel. I am just copying and pasting those over so that we can kind of streamline our process for right now. So I created the scatter plot. So recall that we want to predict franchise value based on annual revenue generated. We want to predict value from revenue. So that's why I have revenue on the x-axis and value on the y-axis. So I just put our scatter plot, and I went ahead and just put that regression line in already, but I left out the equation this time. So what we can see is that as revenue increases, value increases. So we should expect a positive linear relationship between the two. Okay, so done with the scatter plot. Now we want to determine our regression coefficients. So I just used Excel to do this so we don't have to do it by hand, because that's ultimately how you'll do your homework. And here's our table. So we can see that we have coefficients of negative 1,000 for our intercept and 8.5 for our slope. So if we wanted to write our equation up here, we would have y, or if I want, I'll say value is equal to negative 1039.5 plus 8.58 times revenue. And that makes sense because we have now a positive coefficient. It's not negative, and that makes sense because this line is increasing. And the negative 1,000 also makes sense if you thought if we were to bring this line down here, it would be somewhere in the negatives, and supposedly it is 1,039. Okay, so part C, we want to interpret these coefficients, so let's do that. So let's do part C. So let's start with the intercept, so be 0. We can see it is equal to negative 1039. Oops, negative 1039, so we would say negative 1039.53. So that means the mean value of a sports franchise with 0 revenue is negative 1,039.53 millions. So millions of dollars. That kind of makes sense. If you don't bring in any revenue, it kind of makes sense that the value of your team is in the negatives. So B1 is 8.58. So we would say, let's recall everything is in millions. So for every $1 million increase in revenue, the value of a sports franchise will increase by $8.58 million. So note that now I'm saying for every increase in revenue, value increases. So increase and increase because we have a positive slope coefficient, which means they move in the same direction. Okay, so part C, we're done. That was interpret. Part D, we want to do some prediction. Predict the mean value of a baseball franchise that generates $250 million of revenue. So we're going to want to rewrite our equation. So part D is prediction. So let's just write our estimated equation. Estimated regression equation. So that will be y hat is equal to negative 1039 plus 8.58x, or value hat is equal to negative 1039 plus 8.58x, not x, revenue. I probably forgot my hat on value. We just want to say hat to specify that our dependent variable or response variable is predicted. So now let's do our prediction. So let's do prediction. So that would be y hat is equal to negative 1039 plus 8.58 times, what did we have? 250. 250. All right, where did this 250 come from? That's from our prediction. So we wanted to predict the value for $250 million of annual revenue. So that's why I put 250 there. And when we calculate that, we get a value 1,105.86. Again, we could say millions of dollars. Okay, part E, what would you tell? Let's do part E now. What would you tell a group considering an investment in a Major League Baseball team about the relationship between revenue and value of a team? So the more revenue that is generated, the greater the value the sports franchise is worth. And that's kind of a no-brainer, at least I think so. If you want to be a valuable franchise in anything, it's not unique to sports, you got to bring in money, you got to bring in revenue to have value. Okay, so I'm going to add a couple more things to this just to reinforce some ideas. So the first is beta 1 significant, or is B1 significant at alpha equals 0.05? Well, let's just go back to our table. So I went ahead and calculated the standard error. So we have our t statistic of 4.89, and we can see it exceeds t critical. 4.8 is bigger than 2, therefore we would reject. Or we could do the p-value approach. So p-value is very small. In fact, it's just listed as 0 out to 3 decimal places, which is less than alpha of 0.05. So we can use either method. So we would say, so is it significant? We would say yes, because p-value is equal, or really, it's less than 0.001, which is less than 0.05, which is our alpha. So hence, we would reject our null of beta 1 equal to 0, and we would accept our alternative, which is that beta 1 is not 0. Okay, let's do the coefficient of determination. So coefficient of determination. So do I have that listed up here? No. Okay, that's fine. Um, I have it in our Excel, so we'll calculate this. So R squared in our that will calculate in the Excel lab is 0.96, and so we would say 96% of the variation in value, our response variable, can be explained by revenue. And so we would probably say this is very good model fit. 96 is very close to 1, or 0.96 is close to 1. And then finally, our assumptions. So maybe I should move these down. Just put them on the next page. So let's just recall, so this would be part H. So first, let's just go through them. Linearity. So does this look linear? Yeah, close enough. You could just draw like a line through this, and that seems reasonable. It doesn't really have any other shape other than like a line shape. So amongst these variables, think of it as like the line of best fit in our scatter plot between fitted values and residuals. So I would say, is linearity okay? Yes. Now we would want two constant variance or homoscedasticity. So constant variance, so it stays pretty consistently where our max values are up here and our low values are down here. So yeah, we'll go ahead and say we have constant variance. 3, independence. So we're really just looking for any like systematic pattern in the scatter plot, and there really isn't one. And again, we don't have a time series, so this isn't a problem. So we'll just say yes. And then finally, normality of residuals. And we can see that there's kind of this bell-shaped curve to our histogram of residuals. So I think we can say that that is satisfied as well. So, okay, well, that's it for chapter 13.